So here we are looking at a branch of mathematics called trigonometry. And trigonometry deals with the measurement of metry, spell that correctly, the measurement of angles and the ratios of sides that exist with right-angled triangles. Now, we're going to do lots of trigonometry throughout our mathematics careers. The start of it is always dealing with the right angle triangle. Now, keep this in mind. Never forget your right angle triangles. We're going to deal with trigonometry and non-right angle triangles later on. But oftentimes I find with older students, when the problems get harder, they seem to forget the simple right angle triangle. So try to remember that as you go through. So what does it all mean? Well, we start with our right angle triangle, and we're going to label some sides. We know our hypotenuse from our work with Pythagoras' theorem. The largest side in a right angle triangle opposite that right angle there. So we know what a hypotenuse means. Now, we're going to label one of the angles, and we're going to deal with this one. So if we take this angle here, and we're going to call it theta. That's the Greek letter theta. The side over here is what we call the opposite side in this triangle. And the side next to it, this angle, we would call the adjacent. Now that's because we're dealing with this angle here. If we swap that angle and put it up there, this side would be opposite and that side would be adjacent, because that's how the triangle would be labeled. So it all depends on what angle we're dealing with. We don't do it with the right angle, it's just one of the other angles here. So what we can do is we can define what we call three ratios. So this angle here will have sides in a particular ratio or fraction, depending on what way we look at it. So there's three that we start to look at, and they're called the sine, the cosine, and the tangent ratios. So our definitions for the sine ratio is to take the opposite side and put it over the hypotenuse. So this, whatever the angle is, taking sine of that angle, we put the opposite side over the hypotenuse. So, and that will give us our sine ratio. If we look for the cosine ratio, that's always the adjacent side, so the side next to the angle, over the hypotenuse. And our third one we call the tangent ratio. We take as the opposite side over the adjacent side. So there's our definition of our three ratios. Sine's the opposite on hypotenuse, cosine's adjacent on hypotenuse, and tangent is the opposite on adjacent. Now, we have those three because the problems we're going to deal with to start off with will rely on us using one of those ratios, because we're going to always have situations where we've got two sides and the angle in a right angle triangle. So that's where our problem's going to be coming about. And if we have the opposite side on the hypotenuse, what we're going to deal with the sine ratio. If we have the opposite and adjacent sides, we deal with the tangent ratio. And if we have the adjacent side and the hypotenuse, we would we'd use the cosine ratio. So it just depends on which sides we have in our problem, and so as to what ratio we're going to use. Now, an easy way to try and remember that is to remember this, what we call SOHCAHTOA. Now, you're probably going to hear lots of this as we go through, but really it's just a simple way of saying that the sine ratio is equal to the opposite divided by the hypotenuse. The cosine ratio is the adjacent side divided by the hypotenuse, and the tangent ratio is the opposite side over the adjacent side, so divided by the adjacent side there. SOHCAHTOA, it's an easy thing to try and remember, but it just makes sure that you don't mix up any of your ratios here, and we use the right one, and when we look at our problems and look at the sides we've got involved, we get that right ratio. So SOHCAHTOA, remember it, write it down when you do some problems, and hopefully you won't go too far wrong with it.